So last class we have discussed about stack, which is a linear data structure. And what is stack? Stack is an ordered list in which insertion and deletion done at one end, which is called top. And the last element inserted is the first one to be deleted, because what you cannot remove this element unless you remove the top of the element. Okay, hence it is called the last in first out. Whatever the last in, that is will be come out first. So that is last in first out, or first in last out. Philo, you can alternatively say philo, first in last out. So this is the first in, so this is the last out, or last in first out. Now the operations to which we discussed, the two operations, that is called push operation and pop operation. So when we are inserting an element into the stack, that we are saying that it is a push operation. When you are deleting or removing a stack, it is called a pop operation. Now stack overflow and underflow. So this is the two conditions which we have to take care about during the stack operations. What is the overflow condition and underflow condition? So when we are inserting the element, the index starts from 0, 0, 1, 2, 3, and insertion done at one end. Okay, as I have mentioned here, the last element inserted. So suppose the first only one element comes, that is A. So top is my 0. Now B is also inserted. So top will be my 1. Now C will come, top will be my 2. Now when D will come, top will be my 3. So there is the size, that is 4 elements can be accommodated in this stack. So what it will happen if one more element will come over there? Okay, so when one more element will come over there, already this stack is full. See here, stack is full. When one more element will come, that means the stack cannot accommodate that element. That means it will be overflow. So it is a case what is called overflow, when the top pointer reaches at the maximum position of a stack, that is called stack overflow. Now what is the concept of stack underflow? When you are popping out an element. Popping out means what? Popping out means removing. So this top is pointing at D. I want to remove the element D. So I have removed the D. Then I want to remove C. My top is my C. Then I remove B. So my top will be A. Then I remove A. My top will be -1. Because when top is removed, the top pointer will be pointing to the next -1. So here is the case. So now that there is no element present in the stack and the top is equal to -1. -1 is the index in stack we can use. So that is the condition where we can read it. This is stack underflow condition. When top pointer reaches at the maximum position, that is stack overflow. When top pointer reaches at the -1 position and there is no item present in this element, a stack, that is called stack underflow. Clear? Now, as I discussed, this is the same thing I have mentioned over here. Stack underflow is top less than base. That means stack underflow. So overflow is greater than max minimum, because the initiation starts from 0. So it is n-1. If it is 0 to n, suppose n elements are there, then you're moving from 0 to n-1. So the maximum element lies at n-1th index. So that's why if top is greater than max -1, again you want to insert, that means it is an overflow condition. So always stack initialization happens at -1. So stack initialization happens at -1. Okay. There are two ways of stack representation. That is, one is using one-dimensional array, another one is using single linked list. Okay. So as this we have just discussed how to insert this element. We are inserting one element. When we are inserting an element, our top pointer is incremented. When we are removing an element, our top pointer is decremented. Now in linked list also we will see the same things. Here information is there, here the next pointer is there. So now my top pointer will be incremented to traverse the linked list. Okay, as we have discussed, to traverse the linked list, it requires n number of time comparisons. Okay, so it's the order of n. Now there are direct applications of stacks are there. One is balancing of symbols. So there are symbols we know, that is a parenthesis, multiplication, addition, subtraction, division. These all are the, we know that about the BODMAS rule. So that is we can apply here to check whether the parentheses are balanced or not. Again, the infix to postfix. So if there is an expression, how to solve that expression? So there are different types of expressions are there in algorithm. So that is three different types, that is infix, prefix, postfix. We'll discuss later. Evaluation of postfix expression. Now further implementing the function calls. So you people have heard about this recursion. So this recursion can be implemented using stack, because this function is calling again and again. So that's why it is called recursion. Now finding spans. What do you mean by span? Finding spans in stock market refer to problem sections. Okay. Page visited history in a web browser. Page visited history in a web browser means black button. So how many times you visited in a web browser, that thing that can be problem is analyzed using the stack data structure. So undo the sequence in a text editor. You can undo the sequence you have edited, because whatever the last, when you press Ctrl Z, that means whatever the last modification happens, you are pressing the same, becoming to the same situation. Ctrl X, Ctrl Z, all this thing. So undo the sequence in a text editor. Matching tags in HTML and XML. So when you are trying to match the informations with these you have written in XML markup language and HTML language, so you are just comparing. Okay. So how we are using array in array stack? So that way, this is an stack. You are creating a stack of size 8. So suppose this is 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So stack is having 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 elements are there. And from 0, this is because the top is initialized to be -1. So that's why. So I have created a structure of name stack where the items are the elements which is going to be inserted, and top pointer is also required, and the object object of this structure is variable of this structure is called s, and that data type of this s is stack. As I discussed, the top has to be initialized to -1. So s dot top equal to -1. So this is the stack initialization. Now there are two operations we have to check in stack. We know that is push operation and pop operation. So how we can insert this element? Suppose I have to call a function that is called push s comma 4. So I want to insert 4 in this stack. So what I have to do, I have to pass it here. That is the stack address where I am to do, and the element which I am going to address. Now if this is the object, st top equal to size -1. Top equal to size -1. No, top is initialized at -1 now. Top is equal to size -1 is not correct. So that's why if condition will not rule, and then will comes st of items, that -1 plus st dot top. So minus this top will be incremented to 0th position, and where s of 0 is holding this 4. So now this 4 will comes over here. Now again I want to insert 33. Whether it is checking the size equal to -1. So this condition is stack overflow. If top equal to size -1, that is stack overflow. So always you are checking with the overflow condition. The element insertion or the push element in stack operation, push operation in stack can be done till the stack gets overflow. If the stack gets overflow condition matches, then it will come out. Okay. And same goes with the pop operation. Suppose the elements are here. Okay, I want to pop an element. Y equal to pop s. So what I have to do? I have to remove, because here what happens, here I want to insert the things, elements. So that's why I'm passing another variable, another element. But here I know there is whatever the top it is there, it will be come out. I don't bother about what are the elements. So I don't pass any parameter over here in this function. So what I have to check, I have to simply check whether top equal to -1, the opposite one. So top equal to -1, no, top is at 0.4th position, I maybe. So 0, 1, 2, 3, 4, 5, fifth position. So that's a 12. So this condition will not match, and then will return S top of minus. So you remove this item, whatever the item is there, and decrement the top counter to the next one. Okay. Now same thing, it will go till it reaches to this fourth. Now when it rerun, then this 4 will come out and this pointer will be initialized to -1, so that no further removal or popping element can be done using in this stack data structure. Okay, so two condition: stack overflow, stack underflow. Overflow means when it reaches to the maximum size -1 because it starts from 0, and minimum is popping means you have to underflow means, so you have to check whether the stack top pointer is equal to -1 or not. Okay, now there are some to do these things. There are other functions also we can see in stack, that is empty. So if your stack is empty or not, so because we have discussed this thing in array, so now we are focusing on shifting to linked list. So how we are doing in linked list? So linked list, just a minute. In linked list, so we know that this is a node has to be connected like this way, and this node has to be point to null, so that this is the last node and this is the data part and this is the address part, info part. So this is the node 1, this is the node 2. If node 2's next part is pointing to null, so that means this is this linked list is containing 2 elements. Now what I am doing here, I have a top pointer. Okay, so top pointer equal to null. No, if because if this is the first element, top pointer should be point here. If top pointer is pointing equal to null, then means there is no element present. Okay, else then what I have to check? Make empty. Suppose I want to empty, that means what? We are popping out. Okay, so while top pointer not equal to null, move. While top, because top pointer is here, so that is not equal to null, so move what? Temporary pointer. So a temporary pointer is there, so temporary pointer will be, so this is a temporary pointer now. Okay, temporary pointer will be my top pointer. Okay, pointing to top pointer, and top pointer is pointing to top pointers next. So now this 2 will be my top pointer. This 2 will be my now new top pointer, where because temp is pointing to previously top, so now top is incremented to top of next. Okay, now a top pointer of next is now equal to null. Top pointer of next equal to null, because we can only delete the element if it is the maximum position. So now the element is at the miss position, so I can remove this pointer. And what is the remove this pointer? So remove this pointer is this temp, because top is already pointing to these things, maximum -1. So remove this temp pointer. So remove this pointer means this element is deleted, because in stack what happens? So first 2 will come, okay, then 1 will come, so then 1 will come. Okay, so in this way it is stored. Okay, so suppose this is 1 and this, suppose this is, sorry, suppose this is 1, this is 1 and this is 2. Okay, so 2 will come over here and 1 will go upon there. So what I am checking, while top pointer equal to null? No. So temp pointer will be pointing to the top pointer. So now this is my temp pointer here. Okay, and top pointer will be pointing to top pointers next, that is here, top. So this is my top. So now as my top has shifted, so as we know that top will be pointing to the next node which is having the element, and this, so I can easily remove this one element from this stack containing representing linked list. So this is removed. Now only I have this 2. If again I have to remove, that means equal to null. So now next one is the is full condition. If it is full condition or not checking. So what happens then? So there is a extra pointer is not required. We have to check at the location. So location is new node type item test. So you are checking, creating a location for that. Now, if location equal to null, so suppose you are transforming that variable equal to null. No, if it is not null, then what you have to do? Delete that location. If it is not null, then delete that location. Now, in push operation, how to do this push operation? So as we just discussed, so you have to create a new node because you have to dynamically allocate memory. So for these things, so for this location variable, so you have created a location variable now. So this is a location variable where locations of info, because location is a linked list, so there is two information should be there, that is data and info. So locations data info, you can say info or next part. So this is info and this is next part. So locations info is my new item, whatever the item I am going to store. So location was suppose 10, locations info will be stored 10, and locations next will be pointing to top. Locations next will be pointing to top, and this top pointer will be pointing to location. So now this establishment is relations is done. So what I was doing, first I have to create a location using the data type, and then the locations info will be that my element, and the locations next will be my top pointer, and top pointer will be pointing to this location variable. Now this establishment done, location has been created, so item has been inserted successfully. Now for popping, you have to create a temporary pointer because you have to free that pointer. So temporary pointer is created, and then item equal to top pointers info. So now my top pointers info is what? This one, suppose 10. Okay. Now temp pointer equal to top pointer. So there is a temp pointer will be created. So top, which is going to be pointing to top. Okay. Now top pointer equal to top pointers next. What is the top pointers next? This one. Okay. This one. This next part. Top pointers next. Now delete next one. Delete this temp pointer because temp pointer is pointing to top and top is already shifted. So top is indirectly temp is pointing to the this node. So I am deleting this temp pointer. So that means this element will be get deleted. Am I clear, students? Itisha, Sagnik, Vivek?
Yes, sir.
Okay. Now we are comparing because we have checked two operations or two implementations of stack. That is, one is array implementation, another one is a linked list implementation. So constructing means creating a new element or that is a constant operation here. In stack, this is a constant operation. In array, this is a constant operation. Everything, like if you want to make empty, if it is a full condition, if it's an empty condition, you're checking, if you are pushing an element or putting, removing an element or destructing. So all are doing in a constant time. So this is a constant operation. Okay. But here, two operations, that is to make an empty and to destruct. That means to make an empty, what is to do? I have to traverse all the linked list. Then only I can simply enter, make the things empty. Because suppose this element is there, and this element is there, and this element is there, this element is there. So and this is pointing to null. So if I want to make empty, I have to traverse these things, then I have to free this entire thing, because this is null is pointing to the, I can know that null is pointing to the last element. Until unless I will not traverse this linked list, I will not able to delete the entire linked list information. So I have to remove first this one, this one, this one, this one, and as I reach to null pointer, that I know confirm that this I have to reach at the null pointer, that is the last value, and I finally link it. So that's why here the operation takes order of n. The same goes with here. But apart from that, all other operations is similar to array. Now Now, array versus linked list in stack implementation. So what array-based implementation is, because it is simple. So the objective is simple. Okay. So the size of stack must be determined when stack object is declared. Stack object is created with the help of a structure. If you are using an array, you can create a structure and create a variable, structure variable, and initialize that variable top equal to, or s dot top equal to -1. Okay. Space is wasted if you use less elements. Suppose I have, because array is static in nature, so you have to create before the use. So I have created 4 elements, 4 storage location array. Suppose this is the array having 4 elements can store, but I can only store only 2. Then this memory is not unused, remain unused. So that is the issue with only array based implementation. So we cannot enqueue more element in that array we can hold. Okay. And regarding linked list implementation, it alleviates the problem, but time requirement might increase, because so every time you are creating a memory for a new node, every time we are creating, you are traversing the linked list, then only you can reach at the last position. So that is the thing which is makes a linked list is time consuming, as we discussed in this example. Now, before coming to the applications, see here I have mentioned these are the applications. Okay, these are the applications. So first application we will check, that is the balancing of symbols. Now, what is balancing of symbols is doing? Everyone know that this, if this is the start, then this should be end. If this is the start, then this should be end. You cannot write this way only. Okay. So if like this way, so what I am saying, the algorithm says that, so read a line of text. So first you have to read a line. Suppose this is the stack. Okay, let's wait. Suppose this is the stack. This is this, or this. Okay, so this is not there. So this is there. So what I have to do? I have to insert this element. So read a line of text while the character in line not equal to null. So character line not equal to null means this is the symbol. This symbol indicates that if it is not reaches to the null value, this is the nothing but the null symbol, as you also studied in C programming. So this is the null value. If it is, the character is not null, that means when it will happen, this is 1, 2, 3, and this at this position, this is null. Okay. So what I am in array, what we are going to store? So this is the parenthesis, this is this, and this is this, and this is /0. So while read a line of text, while character in line not equal to 0, push the character into the service. So first what it will come? Right parenthesis, sorry, left parenthesis. So left parenthesis comes. Then right angle square bracket. Then left square bracket and right square bracket. Then if stack is empty, now the condition is null. Okay, so you cannot consider, because here all the elements are full. Now I have transferred into the stack. So this is the array and this is the stack. Okay. Now what condition is checking? While the stack is not empty. If it is not empty means, if till that you can insert the things, then you remove the elements, character and display. So you have to remove this element and display, so that you will understood. I'll give you example, better example in next class probably. So that's why I'm just following the algorithms. Okay, then see, just wait. I'll see, tell you right now only. Just wait. Okay. Suppose, actually I did a mistake over here. Okay, I have to correct myself. This is not balancing problem. This is a reverse line text. Okay. Suppose I wrote my name here SIBUN. Okay. So read a line of text. So how this array will be stored? In this will be stored till null value. Okay. Now read a line test where the character in line not equal to 0. So you are reading, now pushing that character into stack. So read a line, character character is my S, second character is my I, third character is my B, fourth character is my U, fifth character is my N. Next will be not there, okay, because it reaches to null. So what I have to do, I have to empty that stack. Now pushing is done, popping is now. Now what is the first element? Because this is a stack, so last in first out. So last in is N, so N will be come over here. Then the top pointer will be pointing to U, so U will be coming over here. Then the top pointer will be pointing to B, B will be popping out. Then the top pointer will be popping out to pointing to I, then I will be popping out. Then the top pointer will be pointing to S, then S will be pointing. Then the top pointer pointing to null, that is the -1 condition. So that means there is no more popping can be possible. So that means I have reached my reverse of a line or a text or a word. So first you have to insert. Once it is being full, then you have to, or the line reaches to null, whatever you want to do. If then you remove that elements, that is NUBIS. So I have successfully reversed a line. Am I clear?
Yes, sir.
Yes, sir.
Sagnik,
Yes, sir.
समझ में आ रहा है?
हाँ, sir.
Now, next example is balancing the parentheses. So here comes the balancing the parentheses. So read the expression as line of text. So suppose I am giving an example, just read. I am writing A plus B, thus this much only. Or I can add multiplication to C plus D. Okay. This is, so I forgot, because this A plus B is done, this multiplication is done, this is correctly done, parenthesis start and C plus D. So this parenthesis I have missed. So this is, that means this expression is not balanced. So how to do this, solve this sort of problems? So this is the algorithm. What you do, read the expression as a line of text. So you have to read this as a text line. Now while character in line not equal to null, so that's why still this is the null position. So that's the first character, second character, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th. So 12th position, the null is there. So till 12th position you have to traverse. Now what you have to do while traversing, if character is left parenthesis, so that's why this one is the left parenthesis, push that character into stack. So I am pushing it into stack. Okay, left parenthesis done. Now next element, left parenthesis, stack. Then next element is not left parenthesis, then what I have to do else, if character is the right parenthesis, okay, character is not right parenthesis, okay, else if character is right parenthesis, so if character is right parenthesis, what I have to do, because this is not a character, so I have to traverse, this is not a character right parenthesis, this is not a one, this is the right parenthesis, so this is the right parenthesis. So till that time I have to increment the things. Then what I have to reach, if the character is right parenthesis, suppose I reach at this point 0 1 2 3 4 5, fifth position. Then what I have to do, if the stack is empty, okay, parentheses are not balanced. Okay, pop the left parenthesis from the stack. If so, right parenthesis I have reached, so I have to reach here, then here left parenthesis again come, then right parenthesis is not there. So if the character is right parenthesis, there is no character right parenthesis, so that means insertion is going on till that when this condition falls, where the character is right parenthesis, character is not right parenthesis, so we have to insert. So if the character is right parenthesis, if the stack is empty, parentheses are not balanced. So you have to so parenthesis is not balanced, and you have to pop up the error, because the final one has to be the right parenthesis. If that is the top position, or we are reaching at the stack maximum position, if it is not the right parenthesis, you have to remove that things. So that means that is not balanced. So how to do this? You have to left parenthesis from the stack. So you remove this left parenthesis because this is the left parenthesis. So you remove these things. So this is the right parenthesis. So then this is the left parenthesis. This is the right. So if stack is empty, parentheses are not balanced, because if then becomes stack empty happens. So how many right parentheses here? Only one. But here left parentheses are two, and stack is reaching to the null position. So that means the parentheses are not balanced. So parentheses are not balanced. If stack is empty, parentheses are balanced, else parentheses are not balanced. So while to reaching this, if parentheses are not balanced, then it is an issue. Okay. Now next thing is infix to prefix postfix operation. So what is infix operation says that it is A operator B. A operator B. Postfix is operator AB. Prefix is AB operator. A plus B minus C. Now this is between two operator. If between two operand, if operator is present, that is called infix. Then between two operand, if operator comes prior, that is called prefix. And if operator comes post to the operands, then it is called postfix. So A, where A, B are two examples. So this is the small example which I have put over here. So this is the left parenthesis, A plus B, C minus D. So what I have to do, first I have to solve this one, because this is the parenthesis thing. So what I have to write, because if I have to do prefix means the operator should be comes prior. So what I have to do first, I have to write first AB plus. I have to write first AB plus. Then what is the next? It is multiplied with C. Then what I have to do? So AB plus AB plus AB C. This multiplication will come prior. Okay. Now what else is there? Minus D. So this is the thing and this is the operator. So what I have to write? Star plus A, B, C, D, and this minus will go to first position. So minus star plus A, B, C, D. So this is the thing. Okay. Now coming to this postfix. Postfix, how? As we discussed, this is the thing like operator will come to the at the post of the things. So like I want to solve this one only. So what will be right? AB plus. First it will be answer AB plus, then into, then C minus D, then into is there. So what I have to write? AB plus C, then this into will be over here because post, then minus D. Now what I have to write? AB plus C into D. This minus will go post. So this. So AB plus C into D minus. Okay, done. So this is all about infix to prefix and postfix expressions analysis. So this what I have explained, just I have mentioned over here one by one. So A plus B into C by D minus C. So prefix operations is, So what I have to do, because this is first I have to traverse from left to right. So while traversing from left to right, so I reach at multiplication. So we know that multiplication, addition, division is giving the same priority. So multiplication will be executed first. So star BC will happen because this is a prefix. So operator will come prior. Star BC, then slash DE. Then the division will be executed. So division star BC D minus E. Then the addition and subtraction has the same importance. So first addition will be done. So because we are coming from left. So slash or division multiplication BCD with plus will come over here and A will be here, because this is an operand and this is an operand and this is the operator. So this operator will comes to here. Okay, so A will become here plus A slash star BCD. Then minus C. So minus is here. So minus will be go to here and minus plus A slash BCDE. So this is the prefix. Now postfix. Postfix means what? Operator will become letter. First operands. So BC star, because I have to solve this thing first. So this will be BC star. Then the division, then BC star D slash. Okay. Then the addition, BC star D slash, ABC star D slash plus. So this plus will becomes letter. Now this minus will become letter. So ABC star D slash plus E. So this is the postfix expression analysis. So next class I will explain you regarding the evaluation methods or algorithms, how we can do these things.